All right, so here we are at Chapter 9, Problem 9. We've got a 2-meter long plank, right? 2-meter long plank. The mass of the plank is 20 kilograms and can be considered to be a single force right at the center. So the mass here is going to be mg, so 20 kilograms times, right, 9.8. Person holding it is exerting a force F1 down on the end, and then 50 centimeters in, which would be, okay, right there, right? All right, is exerting a force F2. So overall length is 2 meters. That puts this in the middle and the 0.5 meters from here to there. Right? All right. So the question is, what are the magnitude and directions of F1 and F2? Right? All right, let's start working it out. So if we look at the total force, right? The total force, and I'm going to leave, let's assume, well, we drew, let me back up just a second. All right, as I drew them, right, mg is down, F1 is down, F2 is up. Okay? All right, so the forces. All right, the sum of the forces is going to be 0 because the plank isn't accelerating up or down. And so the sum of the forces are minus F1 because it's pointing down, plus F2 because it's pointing up, minus mg equals 0. Put the 0 in there. 0. All right? So that is, that's our first equation. This is the sum of the forces, right? Sum of the forces. All right, and the sum of the torques must also be 0. And to make things easy, let's put the pivot point at the end where F1 is. That means the torque due to F1 is 0, right? Because F1 times 0 is 0, right? The torque due to F2. Now, F2 would be a positive torque. F2 times 0.5 meters, right? F2, oh, no, that would be a negative torque, right? Be a negative torque because that is a clockwise rotation about F1, right? And then the weight, mg, times a meter, well, that's a counterclockwise rotation, so that's a positive torque, right? Times 1 meter, because the center mass is 1 meter from the end. All of this adds up to 0, right? So F1 drops out of the second equation, and we get her left with F. If we solve for F2 equals mg divided by 0.5 equals 2 mg equals 2 times the mass is 20 kilograms times 9.8 meters per second squared. All right, and 40 times 9.8, 40 times 9.8, 392 newtons, right? 392 newtons. All right, so back to the first equation. We solve for F1. F1 is F2 minus mg, right? Which is 392 newtons minus 20 kilograms times 9.8 meters per second squared. All right, so equals 392 minus 20 times 9.8, 196 newtons. 196 newtons. And there you have it. So F1, pardon me, F1, because of the sign convention we used, downward, right? And F2 upward. All right? And that's it for problem 9.